Let's look at some fundamental counting principles. Imagine that you're getting ready to purchase a vehicle and you have two choices of vehicle, a car or a truck. There are 5 different colors from which you can choose, maybe red, green, blue, black, or purple, and 3 different models, the X model, the Y model, or the Z model. So how many ways could you purchase this vehicle? Let's look at a tree diagram. Here are your 2 vehicle types. There's a car and a car on the right, a truck on the left. That leads to a color selection. So whatever one you get, you got 5 color choices, red, blue, green, black, or purple. And then whichever one of those you choose, now there are 3 models from which you can choose, the X, Y, or Z model. So the end of this tree, all of these branches, lets us know how many ways we can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 30. So this tree diagram allows us to see all the ways that we could purchase this vehicle. This is a great visual aid, but it would be a lot of work to draw tree diagrams every time we want to figure out how many ways we can do things, all the possible outcomes. So we can use one of the fundamental counting principles. We've got these different possibilities we need to consider: vehicle type, color, and model. The vehicle type, there's 2 of those. The color, there's 5 of those. The model, there's 3 of those. And we're going to need to multiply these because they're dependent on each other. It's one and another and another. So we'll multiply. And that gives us the same answer, 30. But it's much faster. So here's fundamental counting principle number 1 with and, when they're dependent on each other. So if you can make one selection A ways, and then you got another one to make B ways as a result, and C ways, and it just goes on, you multiply those possible outcomes. That's what we just did with this vehicle selection. 2 types of vehicles, 5 colors, 3 models. We multiplied the possible outcomes for each and got the total outcomes all together. So you try this one. We're at an ice cream place and you can choose 1 size, 1 ice cream flavor, 1 sauce, and 1 candy topping from a collection of 3 sizes, maybe small, medium, and large, 10 flavors, 4 sauces like maybe hot fudge or butterscotch or peppermint or strawberry, and 7 candy toppings like crumbled up Oreos or brownie bits, well, whatever they are. How many ways can a customer create a sundae? Please pause the video and figure that out. Here's how you can do it. These are the 4 things from which we're going to be choosing: size, flavor, sauce, and toppings. And we're going to multiply them. One leads to another. There's 3 sizes, 10 flavors, 4 sauces, and 7 toppings. And when we multiply all those, there's 840 ways. With 365 days in a year, it would take you over 2 years to get every kind of sundae there is. How about this one? How many 4-digit odd numbers can be written using only the digits 7, 8, and 9? Well, when we have 4-digit numbers, we're looking at integers here, we've got these places. For the thousands place, 7, 8, or 9, any of those are okay. For the hundreds place, 7, 8, 9, they're all okay. And for the tens place, 7, 8, 9, they're all okay. So there's 3 possibilities for each of those. However, the 1 spot is where odd and even are determined. 7 is okay, 9 is okay, but 8 isn't. So there's only 2 possible things we can put into the 1 spot. And now we can multiply these together. 3 times 3 is 9, times 3 is 27, times 2 is 54. What if one event doesn't cause another event? So if you need to buy hamburger buns for a cookout at just one store, and you can get them at one of 4 supermarkets or one of 3 bakery shops, how many ways can you purchase the hamburger buns? The key word here is or. So when the events are what we call mutually exclusive, it can be made A ways or B ways or C ways, we add the possible selections. So in this case, we've got 4 supermarkets and 3 bakery shops, and we're going to add them. There's 7 ways you can get the hamburger buns if you're just going to go to one store. We'll wrap it up with this. If you create a passcode with a maximum of 3 characters, and all the characters have to be capital letters, how many passcodes are possible? Well, it doesn't say exactly 3 characters. It says a maximum of 3 characters. So we've got 3 mutually exclusive situations. 1 character, 2 characters, and 3 characters. They're all apparently okay for a passcode. So we'll have to find out what's up with each one of these 3 and then add them together. Okay, for the 1 character passcode, there's just 1 spot to fill in. For the 2 characters, there are 2 spots, and for the 3 characters, there are 3 spots. They have to be capital letters, and there are 26 letters in the alphabet. So we'll put 26 in all those spots, and then we can just do the math. And there's 18,178 ways because we have to add the 1 character possibilities to the 2 character possibilities and add those to the 3 character possibilities.